Okay, so this is the last number. This is the number 7 actually. So we have here the x cubed plus x over 2 minus 8 equals 0. So what we're trying to find here is the real root, right here, denoted by the alpha. So if you try to use your calculator, you will find out that the value of x is 1.9 something. So I'm gonna discuss that later. I'm gonna show you first how to write the solution. So by the way, guys, there are 3 ways at least to do this. Number 1, using your calculator, which is the easiest one. Number 2 way, the second way, is using the graph. Okay, you can just put the graph. Just be careful that you have the 2 sides, the left side, so graph that, graph also the right side. And you just have to identify the intersection. Okay, but just looking at the intersection, you will have a good estimate of the integers right there representing this. So the third way is, of course, the algebraic way, which is to write your solution, but of course with the help of the calculator. If you don't have a calculator, then you're gonna have to do it manually. Okay, so this is how you will write your solution here. So the first one, I'm just gonna have to isolate x cubed first, 8 minus x over 2. So what I did here is I just moved the 2 terms to the right side. Right here, careful with your sign. What I'm trying to do is to isolate the x, so I'm gonna extract the cube roots. So this should give me x equals the cube root of 8 minus x over 2. Okay, the next thing is I'm going to convert this as a formula. Okay, so x sub n plus 1 equals cube root of 8 minus x sub n over 2 right there. So just like that. So now it's a formula. So step number 1, 2, and 3. The next step is for me to assign a value of the first x. So we always want to start somewhere. Here it's not important where you start. However, of course, it's an advantage of yours if you start at a good estimate. So I'm gonna estimate just 3. You can start at 4, 5. However, just make sure that the inside is not a negative. Right there. So I'm gonna start with x sub 1 equals 3. I'm gonna put the line here. X sub 1 is equal to 3. X sub 2 therefore is cube root of 8 minus 3, which is x sub 1 over 2. Okay, so this will give me a value of 1.866. Okay, if I just want to write the 4 significant figures. However, I'm gonna extend this to the 5th decimal place just to make sure that my final answer will be as accurate as possible as it can be. 866, I'm just gonna copy 2 more, 2, 6. Okay, so 5 decimal places. Next one, I'm gonna compute for the x sub 3. Okay, that's cube root of 8 minus x sub 2. If you're using your calculator, just press answer for the place of x sub 2. So that will make it easier for your calculator and more accurate for your calculator to compute right there. So this will actually give me or if you've entered the formula into your calculator, you can just keep on pressing answer or equals. Okay, right there, 91900. I'm gonna go for 4 until I observe a consistent answer. My answer now is 1.91661. x5 is equal to 1.91672. x6 equals 1.91672 again. Okay, I can continue this forever. Let me just try x7, x sub 7 equals, I'm gonna get 1.91672. So as you can see, it's pretty consistent that you have 1.91672. So if you continue this x7, 8, 9, and so on, you will get a consistent answer. So 1.916 is a decimal number in between the consecutive integers 1 and 2. So this is now your answer, 1 and 2. Okay, so that's how you want to do this. However, if you just want to grab your calculator and press the button to get the answer, just press the mode. Okay, get to the equation. So depending on your calculator, just find the equation mode and just find the cubic equation. Okay. Right there, and from there just have to type the coefficients of the terms. So we have there, I'm just gonna type that, okay, equals. So here I used my calculator and I got 1.91672. So the exact same answer that we got. That's the first x. If I press the next F, I'm gonna get an imaginary number, another one, another imaginary number. So only one x is real root, the other two x's, the values, are imaginary. So right there. So you only have to consider 1.91672. So that's how you want to do this.